is using proportions in similar triangles. Now here's what I'm going to try and do, because we were missing some people yesterday. Now I know if you were away yesterday, you went right to my website and watched the video carefully so that you knew what was happening when you came back today. I know you did that. But even still, I'm better in person than on a video. So I'm going to teach this lesson as if I'm teaching the people who were here yesterday and the people who stopped talking while I was teaching and the people who were away yesterday and don't know what the heck is going on. Oh, a fourth group of people I'm going to teach today. The people who have been here, have been listening, but aren't sure exactly what's happening. It's the perfect lesson for all that. Tests back, marks back, I got everything as long as I finish the lesson in time. I got it covered. And a little speech about marks and so on. Ready? Using proportions. Okay. Proportions. When you see that word, most people in this class and in previous classes, you don't have to take my word for it. Other groups of grade 10s haven't minded proportions. Once they understood what proportions were, they were happy with it. So just put a little note on your note here, a little arrow, and put the words cross, multiply. If we've got proportions, we'll be able to cross multiply. I put a question mark, not because I'm wondering, but because I hope that's what you're asking yourself. You say, oh, if we're doing proportions, will I get to cross multiply? We had another name for it. Who had the catchy name for it? I forget. Butterfly. I see proportions in the title, and I'm like, okay, good. Cross multiply. I'm going to cross multiply at some point. Next, in similar triangles. Okay, those of you who were yesterday got an intro to similar shapes, not a complete idea of what similar shapes are. And this is where I'm teaching two groups at once. So here's an example to talk about what's a similar shape. And here's an example. The two triangles below are similar. Here, underline that. Are similar. Whoops. I figured out why it does that now. When the other pen's too close to the board, it gets confused. Are similar. These triangles are similar. I don't even know what similar is. I know. Let's look at them. Take a look at the two triangles that are similar. What do you notice about the triangles? What is exactly the same about both triangles? The angles. There. Now, those of you who are away are caught up halfway. Oh, to be similar, all the angles have to be the same. That's always true. I'm not going to change that rule. That's always going to be the same. What's the same? The angles. And I'm writing short sentences today. Just writing exactly what you need. Not because I'm not an English teacher, but because I want to write just what you need there. What's the same? If it's similar, the angles are the same. And I'm going to write a little arrow here for your reference if you have to look back at this. If it's similar, the angles will be the same. And vice versa. Watch, I'm going to put another end on that arrow. If all the angles are the same, then it's similar. That's an important detail to know too. If you see all the angles are the same, you get to say, these are similar. Okay, why do we care? Well, we care. Here's why we care. If it's similar, we can do proportions, which most grade 10s like. Not like Mr. Todd's nerding out doing math and he's excited about this. I don't mean that. I mean, literally, grade 10s are like, hey, compared to that quadratic stuff, I like proportions. You just cross multiply, and you get the answer, okay? Other patterns. What else do you see? We might need somebody from yesterday who knows what to look for to see what's happened with the sides. Alex, what do you see?
The perimeter got doubled.
The perimeter got doubled. Absolutely, the perimeter got doubled for a very specific reason. How did the perimeter get doubled? Look at the individual sides now. He's not wrong. The perimeter got doubled. It's not what I'm going to write here. Or maybe I'll write it over here before I'm done. I will write it. What happened to the individual sides in this particular set of similar triangles? They all got doubled. Yeah? Sides all doubled. And I wrote it wrong. And I'll write what he said too, what Alex said there. And that meant the perimeter doubled. And we could do a perimeter question, but we'll do a lot of side questions. We'll look at the sides. Maybe the numbers don't work for you. Here's what we mean. Look at these two sides here. I'm going to switch to festive green here. Look at these two sides here. 10 divided by 5 is 2. If I take the bigger and I divide by the smaller, I get the proportion. I get how much bigger is it. And that happens every time. Look at, I'll do it with the 3 and the 6. 6 divided by 3 equals 2. And finally, the last side. This is getting messy. You don't have to write this if you don't want. It's more of a, if you're watching the video thing, or if you didn't see how we knew it doubled, we just looked at the individual sides and divided them till we find out what it was multiplied by. Somebody raised their hand and goes, no, that's not how I did it. I could just see they were doubled. I know, but if the number's not 2, if it's a 3 or a 5 or a 6.2, you'll have to divide to find out what that number is. In conclusion, in similar triangle, corresponding angles are equal. And now I'm getting ready to use my fancy word here. Corresponding sides are proportional. And by proportional, we should be able to set up ratios to cross multiply. And several people, not just one. So if I tell this story and you think I'm talking about you, I am, but there was at least 3 people who came up to me and said, I don't really get what's going on here. I'm not following. I'm like, wait for this lesson. This lesson ties it all together. And you might be like, oh, well, that's not so bad. I can do that once you see me do the examples. Coming up. Gentlemen, everything's okay? Missing a desk? Alex, can we have this desk? Or are you just going to sit there? You can do that too. We can move it if you want. Did you write down the fancy proportional word? If right now you're still writing down proportional going, he's really on about proportional. He's really excited about that word proportional. I don't know what it means. That's okay. At this point in the lesson, it's okay to go, I still don't know exactly what you mean by proportional. That's coming up. That's why this lesson's so good. It's the most important lesson. It all comes together. If after watching this lesson you want to go back and watch one of the old videos, I think you'll understand everything. If you understand this one, all the other stuff will fall into place. Do you need more time, Isla? We're okay? Yeah. All right. Here we go. This is where the technical stuff starts. Get ready. Since these are similar triangles, angle A and angle P are the same. Okay, I'm just getting used to these new symbols. Actually, I'm not going to do anything new here. I'm just going to use fancy symbols to say the same thing. Angle A, right there, is the same as angle P, right there. And what is that measurement? 80 degrees. They're both equal to 80. If you're right with me, if you understand what I'm saying, now you're bored. You're like, are you just writing the same stuff again? And the answer is, yeah, I'm really trying to pound this idea home. How about B and Q? They're both the same. There's B. There's Q. They're both 40. Because they're similar triangles, their angles are the same. If you get one that's different, we can do those kind of triangles. And we will. They're just not called similar, that's all. It wouldn't be in the lesson called similar triangles. The ones today are all going to be similar. You're like, what do we do if they're not similar? Okay, that's why you're paying me to come in every day. I'll come in another day and show you ones that aren't proportional.
We don't pay you.
Well, the system pays me. You wouldn't? Is that what you said? You wouldn't. All right. And how about angle C and angle R? They're both equal to what measure are they? 60. Now look here though. I'm going to do it the other way just so you see. I'm going to get out my color coding to show how the sides correspond. What that means is AB, which I'm going to color in green. Yes? You don't need another color. Because I'm going to come up with a way that you can just do what I'm doing but not use a color. AB matches up with PQ. the notes will often use the word corresponds. But I'm going to try and use matches up because I find that word's easier for a lot of people when they're first learning this. Those two sides match up. See, AB and PQ are matching sides. They're not the same length, but they're matching sides in the two triangles. And so it's 5 over 10, which is 1/2, which is 0.5. And what I'm saying is the triangle on the left is half the size of the triangle on the right. Wait. I don't know. I think it was 189 this morning or something like that. A little up. That's not that bad. I got to hibernate this winter. I got to be ready. Can you get what?
My Cheetos. From my locker
After the lesson. That's beautiful. We've come so far.
I can get them?
We'll see. Let's see if you do a couple questions of the homework
will.
first. All right.
Oh, that's
No, she's learning to be honest. It's nice. We've come a long way.
because I got yelled at by a teacher. I got it.
Yes. See, this is why I'm doing it again. She's going, I get it now. Now look at, I'm going to, okay, if you've got another color, great. If you don't have another color, do what I do. It says AC, which is this side. Here we go. I'm going to do it with a little squiggle line. I'm doing another color so you can see it. You don't need another color. AC matches up, or corresponds, if you want to be fancy, you want to use the fancy math word, corresponds in this triangle with PR. Those sides match up. And if they match up and they're similar, when I go 3 divided by 6, what do you get when you go 3 divided by 6? 1/2, which is 0.5 again. This is what proportional is all about. The ratios of the sides will be the same in a proportional triangle, in a similar triangle. One more. Oh, I did red and green. I'll do blue now. And instead of squiggly, I'll do lightning lines. I don't know if you've ever seen lightning lines before. Here come my lightning lines. BC, that's this line, BC, lightning lines. That side there, you don't need another color if you're going to do lightning lines like me, matches up with QR, matches up with this side there in my lightning line.
Mr. Todd, that's just a zigzag.
It's a zigzag line. Isla has corrected me. Instead of curvy, it's a zigzag. So BC matches up with QR, 6 over 12. What do you suppose 6 over 12 is? 1/2. And as a decimal? What's that? 0.5. That is the big idea of similar triangles. The angles will be the same, and the ratios of all the sides will be the same. If they're all doubled, they're all doubled. If they're all half, they're all half. If they're all times 5.7, then they're all times 5.7. They're all 1/2, yeah. So AB over PQ equals AC over PR equals BC over QR. And every time we do this, we get 1/2 or 0.5. How are we going to use it? Well, I'm going to reach back and grab your cross multiply trick off the shelf, bring it out of the sheath we've put it in, put it together with similar triangles, and we will have awesome power in solving triangles. Coming right up. First, we're going to try and do this corresponding thing, and then we're actually going to do 2 examples to get you ready for your homework page. Aren't you excited?
Yeah.
Yes. Oh, I was hoping those were actual bells. They're just plastic. I want ones that I go ding, 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 ding.
With the handle?
Yeah. All right. Do you have any questions? Do you need more time? No? All right. Isla, we're okay? I got out of the way enough?
Yeah, thanks.
Yeah, I got it. Oh, this is not where I want it to be. I'm going to move it up. Okay, I'm going to read this slowly. Not because you need it read slowly, just so we're very clear about what's happening. The term corresponding refers to the side or angle that's in the same position of the triangle. For example, in the following similar triangles. Okay, check. They are similar triangles. So all the stuff we've been talking about is true. They're not asking us if it's true, they're telling it is true. They say side AB corresponds to XY. I'm going to do my straight line highlighting of those two sides and see if you agree. I'm going to see if you agree, and then I'm going to get someone, if you do agree, because you're going to be right to agree, then I'm going to say something incorrect. And I'll have somebody argue with me, okay? Do you agree that those sides correspond in the two triangles? Those are the same sides, really. The correspond, they might not be the same, but they're corresponding. Okay, here I go. Ready? Somebody's got to argue. Because what I'm going to say is wrong. Yeah, but in this triangle, AB is on the left. On that triangle, XY is on the right. It's still the same angle, still the same dimensions, and those both represent the height. So they are corresponding. Okay? It's okay? Next, side AC corresponds to side. Okay, you think this is easy because I haven't made this one too tough. But in some questions, this will be a little bit difficult. Don't be scared to use my fancy writing and go, okay, AC, they want AC, so I'm going to do snake line. I'll call that snake line to change its name because Isla didn't like the name I gave the other one, so I'll change it. What would you like to call this one?
That's just like a squiggly.
This is squiggly line. Okay, so squiggly line, which side in the other triangle corresponds? This one's not too bad. But don't be scared to draw the squiggle lines to think it through. What side? XZ is the squiggle line in this one. Don't feel like you're being like elementary to do that. That is, you have to be careful with triangles sometimes and go, which ones actually match up here? That's the only real danger because like I say, cross multiply is waiting in the wings to bail us out, to help us. If we can get the corresponding sides figured out, cross multiply will do the rest. Oh, it said sine AC corresponds with XZ. Now, if you wrote ZX, I'd mark it right, but I'd be like, yeah. Yeah, it's A to C. It's from the top to the side there. It should be X to Z. It should be X to Z. But it's not technically wrong to write ZX. Okay, so I'm not going to. Next, BC. It's the only one left, but I am going to do my, I forget already, Isla. What are we calling it?
What? Zigzag line?
The zigzag line, which I'm doing in another color so you can see. But I hope you agree that you don't need another color. What side does BC correspond with? YZ. Did he say it the right way around? Let me just check for a second. BC corresponds to, B was from the height over to the one out there. So that's YZ. Is that what you said? Yeah. Okay. I'm telling you, that's the tough part of these questions. I set them up pretty nice. They're just flipped over. Sometimes they'll be on an angle, and then you got to be more careful. But I won't be too tricky here. All righty. One more warm-up example before the big one. Before I'm going to wake everybody up who has fallen asleep. That didn't happen today. Who fell asleep? No, don't say that. If you don't remember, it must have been you. That's a good. Who fell asleep yesterday? If you don't remember, it must have been you. Yes. Do you need more time here? See, this is what you get when I have, now that the cafeteria's got Coca-Cola. I'm a little more messed up. Complete the statements below. AB over XY equals AC over what? Do my thing, all right? Don't even try and answer this. AB, what side does it correspond with? It's like the height, so which one is it? XY. Again, trust me, if you're having trouble with these, do this first. Highlight the line so you know which one's which. Then what? I'm going to do green, and I'm going to do
This is hard. Left, go catch him. Go to the right. Down.
Hi. Hello there.
Hi.
How's everything going?
Just to keep it down.
Oh, that's all right.
Or Pete
That's
and
all right.
Alex, I guess.
Can-
Mr. Todd and Joyce. Nope.
No, you can join.
No, he's He wants to go back to art class.
Yeah.
We're just gonna pause and look at this picture, okay, guys?
Have fun. Did I give you enough time? AC. I'm going to do the, what was it? What are we calling it? A squiggle line from A to C. Which one, Jackson, what does that match up with?
X and Z.
Good for you. X and Z. Those correspond. Now, some people, I remember having an argument with a grade 10 student who said, I don't need to put another line on the third. Now that you've done those two, the third one's the one without any squiggles. So that's what I'll do this time. I'll go, okay, as long as you squiggled two of them, you're in good shape. Now, AB over XY equals AC over, what side does AC correspond with? See, AB corresponds with XY. AC corresponds with XZ. Can you see cross multiply coming now? It's laying right there. If we can get this far, cross multiply, we'll do the rest. What's that? Oh yeah, you're right. There better be numbers in here first. But can you at least see the equals and the butterflies? Sort of, it's laying there as long as we get numbers in there. We'll get to the numbers in just a second. Let's try this one. BC over YZ. BC corresponds to YZ. Which one corresponds with XZ? Don't shout it out. Take a second and study it for yourself to see if you can see which side would correspond with XZ. AC is the one. And again, I just want to repeat it. I really want to beat it to death before we get to our big example of the day. Can you see cross multiply coming? If we get two proportion, we get a proportion like this, one thing equals another thing, and they're both fractions, the rest of it will be pretty straightforward. Even if you don't really remember, wait till you see. It's going to be pretty straightforward. So now, I ask a different question. See this little thing here? Put it on there. If you've never seen that before and you know what it means, this means angle. Angle B equals, what angle does B equal? Angle Y. Those angles have to be the same. This is another way to write angles. BAC. Now watch this. Some people kind of like this. I'll get my highlighter out and show you why they call it BAC. You ready? You start at B and you go BAC. That angle there. They're really talking about angle A. It's really the one in the middle they're talking about. What angle does that match up with? YXZ, yes. Have you seen that before? Yes. Like I say, some courses and some teachers will do a lot of that, and some teachers don't. They focus on the relationships and they don't get too worried about the naming. And I'm not saying that either teacher's right or wrong, but some of you might be very familiar with that, and others might be like, oh, that's new and different. But you just ask me and clarify with me if you're having trouble with it. Okay, sports people, the warm-up's over, yeah? Did a lot of stretches, a lot of where are we at, a lot of collecting of people who have been away, who haven't understood, all to get ready for this next example. You ready? No? Katie, what's up?
I was just wondering if this was part of the lesson.
No, that's going to be the homework, which, when I finish the example, should be able to do. We hope. Yeah, all right. Here we go. More time here? We got all our yawns out? I must compliment you. Teaching you in September was completely different than teaching you now. How many times I had to get people's attention, shush people? I mean, we're still working on it, but. What? With the big yawn? In this group?
My fault. I was the one who started.
A lot of anger over at table one here?
I didn't start it. Maybe don't make
Maybe less caffeine would be a good choice for everybody?
She doesn't even drink it.
No.
She's buying it.
All right, here we go. I'm adding a fancy symbol. Given PQR, see this little squiggle? Mathematicians use that. That means similar. They're similar triangles. Now, I won't make you rely on that. If you ask me, even on the test, if you go, Mr. Tao, what does this squiggle mean? I mean, that means they're similar. I'm not trying to teach that, but I throw it in there just so you know what mathematicians use. Say, yeah, I put it right beside it. This means that triangle PQR is similar to triangle ABC. Let's just stop for a second and remember what that means. It means the angles are all going to be equal. And it means the sides will be proportional. That's what's going to happen. So there's my two triangles. It says find the measure of angle P and angle B. I said that in the wrong order. I say first get some squiggles on there. That's what I say. This angle between 50 and 92, I'm going to just do my straight line highlight. Which one does that match up with in the bigger triangle? PR. Don't underestimate that. It feels like, oh, what, I'm just coloring in triangles now? What am I in grade 7? No, no. No, no, no. That's the most important thing you can do. That's advanced math technique. Match up these sides. Now I'll switch colors and do a squiggle line. How about the bottom side, BC? Which side does that match up with? QR. And I'll do what I said, which is, I guess if you squiggle two of them, you don't have to squiggle the third. It's the non-squiggle side. Then you take a break, literally. You do that on your two triangles. You can check your phone for messages. Play 2 turns on Clash Royale. Is Clash Royale continuous? Is it the type of game where you can play a couple turns and then turn away for a while?
No.
Okay, well, see, when you're trying to get stuff done, and maybe you don't want to listen to me, but I'll mention it. If you want to get stuff done in life, switch over to some video games that you can walk away from. I play something called Triple Town. And Triple Town, I can play a couple of turns, set it down, and nothing happens while I'm not looking. Like Candy Crush. Candy Crush is good for that too. You can play a couple of turns, unless you got a treat on timer, right? I only got 10 minutes. Yeah. Can you pause Fortnite?
No, we can't.
No.
I mean, you can pause it, but
If there's other people playing, it keeps going, right?
Yeah.
These aren't great for getting things done. If you're trying to get things done, you want a game that you can pause. Then you can come back. So you pause, and then you come back and say, hey, if I got the squiggles on, the rest should be pretty straightforward. You ready? Don't yell it out. I say then, finding angle B is easy. Easy. You stare at it. You stare at it until either you know what angle B is, or you're like, how could we possibly know angle B? Because it's a good position to be in. You think it's not. Sitting there going, how is anyone supposed to know what angle B is? It's actually a good spot to be in, because then when they say it, your brain's ready, like a little Venus flytrap going, what? What's going on? And goes clunk and takes the information. Is it 38? It is 38.
yeah, I mean, angle P is 92.
She just looked at the pictures and said, what angle matches up here? What's the angle between green squiggle and non-squiggle? 38. Now I say when that happens, write it on the other triangle. When you do get an angle, put it on the other triangle. It helps to see everything that's going on. Next. See how I wrote it too? Try doing the fancy writing. Little angle symbol, B equals 38. The next one I got to do is angle P. Don't shout it out. Look at it and go, oh, I know what it is. Or I don't know how to get it. Is it 92? It is 92. Because 92 in this triangle is the one between the red side and the black side. Or if you've highlighted it, it's between the highlighted side and the non-highlighted side. So that's got to be the same over here. That one's also 92. And so if you didn't like angles before in other classes, maybe in this class you'd be like, oh, okay, well, angles and similar triangles, you just got to match them up. That's all. Okay? Okay, now, listen, folks. It's 2:13 on a Tuesday. That's not the part you got to worry about. I'm going to ask for your question in just a minute, Jackson. This is the part you got to worry about. So I'm going to put a red I'm going to put a red box around this. This is the whole, I won't say the whole chapter, but it's pretty close to the whole chapter all in one question. This is the deal. This is what we have to be able to accomplish. As the Mandalorian would say, this is the way. Jackson, what was your question?
No, I want to start that.
He wants to start that. I want him to start that. Jackson's going to start for us. Find the lengths of sides BC and PR. And by BC and PR, I mean, don't do them both at once. Do BC, and then later on, maybe we'll do PR.
Well, first, I thought it'd be good to find the smallest.
He wants to find the multiplier. I'm nervous. Because everybody doesn't, can we do it second? That's what we'll do. I'm going to do it a different way. Then you come back and say, can't we just find the multiplier? And then see if you like Jackson's way better. Okay? We're going to do both ways. We're going to go after BC two different ways. Do you know the other way I'm going to do? Tell me.
P over Q and A over B is equal.
You're probably right. I just got to catch up, okay? We need BC involved. If we're going after BC, we need BC involved. BC over QR. Those two correspond, to use the fancy terms, equals, now we got to be careful here. You can't use anything. You got to use the ones you know. Which ones do we know?
8.4 and 2.1.
Good. Well, we got to match them up.
Oh, wow.
Is BC the bigger or the smaller one? Smaller. So this is going to be 2.1, 8.4. Now he's mixed the method a little bit. I like it. He said, oh, I know 2.1 over 8.4 is the ratio, so BC over QR, but it looks like I can't do anything because it's not that he's missed something. He's got more information. There's more information available. What's QR? 10. Oh, now we're all the way back to cross multiply. And Jackson's jumping up and down in his chair because he's got a better way, he says. And if you like his way better, I'm not in the business of trying to convince you. We'll get Jackson's way in just a minute. You might like Jackson's way better. Here we will cross multiply. Do you remember how with the butterflies? 8.4 BC equals 10, 2.1. So 8.4 BC equals 21. Do I have enough space down here? Oh, I got lots of space. I get out my calculator and I go 21 over 8.4. What is it? Who's got their oh, I got my. What is it? 2.5? No, what? Oh yeah, 2.5. Yeah. Yeah, it's right. I don't know why I doubted it. I shouldn't have doubted it. All right. Jackson has a better way. I'm not actually disagreeing with you. I might think you're right. It might be a better way. He says, find the multiplier. How are you going to find the multiplier?
Well, first I tried 8.4 divided by 3, but that was 2 point something. And then
Okay, why did you divide by 3?
I don't know, I just tried.
Oh, yeah, okay. I'm going to help you out with your method. I'm going to match up the sides with an arrow saying, those sides correspond. There's your divider. Yeah? So what's 8.4 divided by 2.1? 4. When he punched that in the calculator. He knows the multiplier. He knows the whole secret to the question. He knows that the bigger triangle is 4 times bigger. So then, when he wanted to find BC, did you actually do it? You went 10 divided by 4. And you got 2.5. It's good. It's doing the same thing. It's just a different set of steps. All right. They also want us to find PR. Take a couple of minutes. You or a friend or you on your own, decide if you like Jackson's method better or if you like my method better. I don't care which. I wanted you to see both. It's beautiful that he mentioned that. Try out. See if you can find out what PR is using my method or Jackson's method. Try it out. Or try both. Be like, I'm going to try both ways just in case. What? What happened? What? What happened? Alex, do you have a question or you have the answer? No, I don't want the answer yet. I want everyone to have a chance. So if you just want to answer the question, great. But just wait a couple of minutes while we get everyone back awake and trying this out. I didn't say anything. Stop yelling at me. Oh, sorry. I got to look at everybody. They taught me that in Teachers College. Make eye contact with all your students. I know, but she's taking it personal. Like right now, I'm looking at the people that are sneaking a couple seconds on their phone. I'm being aware of it. So if their mommy calls me complaining that their mark's too low, I can say, well, I catch them on their phone all the time. I don't know what you want me to. Why did you take away their phone? Well, I'm trying to build adults, Mrs. Jones. I'm trying to.
I'm not, is this, never mind, I don't know how to pronounce that. It's like Pythagorean.
The Pythagorean theorem.
Is that what this is?
Not almost, sort of, not really, kind of, maybe.
Okay.
Yeah. Both what we're doing here and Pythagorean theorem fit into something called trigonometry. Tri for three sides and 3 angles. And so it all fits under the same umbrella of trigonometry. All right, Jackson wants a shot at it. What did you do?
Oh, no, I want to say, is Pythagorean theorem not like 90 degrees?
It's for 90-degree triangles and a specific relationship between the sides. Alex, what do you got?
PR equals 6.
Okay, which method did you use?
I did, because like 8.4 divided by 2.1 is 4.
Okay, so he says, hey, I use this information that the bigger triangle's 4 times bigger.
Yeah, so then PR and AC match up.
Yep.
So then I did 1.5 times 4, and I got 6.
This is what he did. No, sorry, not 1.5. I don't know why I wrote that, because that's not what he said. He said multiply it by 4, which is 4 times 1.5, and he got 6. Okay? I'll also show my way, and I'm not setting you up. This is not one of those situations like, oh, you're going to find out my way's better. No, I don't know if you're going to find that out. But the other way to do it was to match them up and go, okay, PR matches up with oh, I can't see it because I scrolled up too far. Like, where are the letters? Over AC equals 8.4 over 2.1. But I know what AC is. 1.5? Yes, it's 1.5. So then I can cross multiply. 2.1 PR equals 8.4 times 1.5. Get out my calculator. What's 8.4 times 1.5?
That would be 12.6.
And I divide that by the 2.1, and I get length 6. I better put the, oh, it didn't tell me whether it was centimeters or meters, so it's whatever it is. Adam, 1 sec. So let me wrap this up. Now, friends, during quadratics, often people are answering the questions in class and then doing none of the homework. We are getting late in the game for you not to learn the lesson from me that the most important part now is trying this. I'm going to do it as well. While you're doing your homework, I'm going to do the homework, and then I'm going to take my answers and I'm going to put them up here in the solution section, and then I'll post them online, hoping that I catch a few people, not catch a few people, that I bring a few more people online going, oh, I'm starting to get what this guy's teaching. If I attempt the questions, then check my answers, I'll be in much better shape when there's quizzes or tests to do. All right, you try the questions out, I'll put the solutions up.